this video, we will highlight the main consideration needed to automate a press brake machine tending application. Press brake, also known as just brake, is a machine used for bending sheet metal for a wide array of applications in the manufacturing industry. Each press brake machine tending cell is different, but let's take a closer look at what should be generally considered to successfully automate this type of application. Let's begin by analyzing the workpiece, as this will allow us to select a suitable gripper and infeed system for the application. In addition to the part's weight, it is important to note that the geometry of the part changes with each bend. If the part is bent several times, it is necessary to consider the area from which the gripper can pick it up before and after each bending, and if the part can be manipulated directly to the next bending position, or if a regrip station will be necessary. The changes in part geometry make the gripper selection crucial to successfully deploy this application. OnRobot offers a complete suite of flexible grippers that can be used for a wide range of part sizes and shapes. These plug-and-play, fully electric grippers reduce programming time and can be quickly redeployed, making them ideal for small batch runs and frequent line changeovers. The MG10 magnetic gripper is ideal for destacking and handling sheet metal. Its magnetic strength can be configured to only pick up one part. The strength then can be increased to 100% to ensure a solid grip while the robot is moving. The integrated part detection sensor ensures reliable performance, and by being a permanent magnet electric gripper, it will hold the part even after power loss or emergency stop situations. Protective pads to avoid scratching the part and fingertips for cylindrical objects can be used to cover a wide range of parts and applications. The MG10's IP67 classification also makes it capable of handling harsh, dirty and wet environments commonly found in machine tending applications. The VGC10 electric vacuum gripper can also handle flat and non-perforated sheet metal. It is a small, lightweight gripper that does not require external air supply and allows unlimited customization capabilities through the use of custom brackets or arms to perfectly fit the workpiece. Both the MG10 and VGC10 are ideal grippers for press brake machine tending applications. Now is the time to discuss the infeed system and how blank workpieces can be presented to the robot. The best results are generally obtained when the workpieces are stacked in precise, structured, and repeatable positions. Alignment pins or fixtures ensure parts stay aligned when the robot is picking them up. If the parts cannot be stacked precisely, it is recommended to use an inclined squaring or alignment table. The robot will drop the misaligned part on this table, and gravity will place it on the correct position for the robot to pick it up again. If the sheet metal needs to be stacked on a moving tray or cart, OnRobot Eye's landmark feature can be used to quickly identify the location of the tray. With the eyes, the robot will be able to automatically reorient all its infeed positions to destack the parts. Let's now focus on how to connect a robot with a press brake machine. Currently, there is no communication standard or convention that all press and robot manufacturers follow. Therefore, it is not possible to offer a solution that works for all cases. Newer press brake machines have Ethernet-based capabilities that allow communication between the robot and machine. This adds robustness to the integration, but requires having the proper communication boards and protocols to ensure compatibility between the robot and machine. For more basic or older press brake machines that lack Ethernet capabilities, the best and simplest strategy is to add sensors and connect signals between the robot and machine. There are three main positions of the machine's RAM, also called beam, that need to be communicated to the robot. These are open position, where the workpiece can be moved in and out of the machine. The robot will use this signal to load and unload the machine. Speed change position, where the machine's punch is above the sheet. This is usually the position where the speed of the RAM changes from a rapid approach to a slower bending speed. The robot will use this signal to release the part. And finally, close position. This is the RAM position where the workpiece is bent to the desired angle. The robot will use this signal to grip the part. 3 position sensors can be installed on the machine to detect these RAM positions. Another common strategy is to detect and measure the full stroke of the RAM by adding a linear position sensor, also called linear transducer or potentiometer. The robot program will then convert the analog signal into corresponding linear positions. This approach only requires installing one sensor and provides flexibility to easily adjust to any RAM position required for different bending angles or parts. This would also be recommended if the robot needs to hold and follow the workpiece while bending. For the robot to communicate to the machine to run the process, it is common to use relays in parallel to the machine's foot switch pedal. The number of relays required will depend on the number of positions and wires on the switch. The outfeed system generally depends on what the next process will be for the bent workpieces. The robot can easily place them into stacks, bins, or pallets. As shown on the simulation, it is recommended to use alignment fixtures to ensure the empty pallet is always placed at the correct position. As a final note, remember to conduct a full risk assessment according to your installation and local requirements before completing the application deployment.